Here's a simple manual water pump I made in case if in a scenario where you have no electricity and you want to move water from, let's say, point A, point B. So this is a test to see how high this thing can pump. So very simple pump made out of PVC and wood. I'll show you the details later, but let's test it. Suction output working. So let's take a look at how high it is. Here's the hose. Yeah, I think that's it there. Pretty good flow. Let's see how fast it can empty this bucket. I'll put another bucket upstairs so I don't waste the water. Okay, here we go. That went down pretty quick. So pumping water up to that height is no problem. Next question is, can it pull water up to that height? So what we have the pail here and the hose running all the way upstairs. Okay, let's see what's gonna happen. Yep. So it is capable of moving water up. So for example, if the pail down there is the bottom of a fairly deep well, I can pull the water all the way up here. So I think it's worked pretty good. Okay, so next I'll show you the details of how the pistons are made. Well, the pump turned out pretty good. So this is just a homemade check valve made out of marble, also over here, and this is the direction of flow. So when you pull the piston up, it sucks the water in this way, and when you push the piston down, the water can only flow this way because this valve is now closed. So you pull it up, sucks in the water, this valve is closed, push it down, this valve is closed, this valve open, and the water shoots out. Now initially when I made this, I think the guy that first made it on YouTube was King of Random. Anyway, he said to use O-rings, and I had a very hard time finding O-rings, and I thought, what about some people in let's say in South America or Africa or some place where, you know, O-rings, especially the right size, is so hard to come by. What can you really use in place of a piston? So I thought about it and I figured, okay, there's something we can use which is quite readily available, which is like all over the place. So let me show you what it is. I'll remove the screws. There we go. Recognize that? It's actually the top part of two bottles. Cut this to size so it fit exactly inside the tube. Down here. This one here, this piston, acts as the intake. When you pull it that way, it sucks the water into the tube. And when you push it this way, this one acts as the output piston. It pushes the water out of the other valve. So basically, this is quite easy to make, and the bottles of course are readily available. This is from Coca-Cola, I think. Yeah, that's what it was. And next thing I'll show you how to actually cut it and shape it. So let's say this is your bottle. To get it to fit, to cut the right size, you take this and insert it in here. Then you take a sharp knife and you mark all the way around, and they'll give you the exact diameter you need. So you can see the mark around the neck, and after that you cut it out, and chances are it will be a very tight fit. And now if you're slightly larger, that's okay, but if you're smaller, then you have to start over. So after you cut it out, like this one here, you can shave it down by sanding it with sandpaper. If you don't have sandpaper, you can use a cement floor, or you can go on the roadway, on the asphalt, and use that. Or if push comes to shove, you can always get a flat rock and rub it down. Or you can even use a flat board, wooden board, with some sand, and you rub it down. So eventually you get two of these made, and here are the details of how to get them together. Now I made it out. Sorry about that, guys, the battery died. Anyway, so this is the detail of the construction, the features. Just two bottle ends with the caps screwed like this, and like I said, should have made it out of PVC, but I ran out, so I used wood instead. I think PVC would be much better. So I made a wooden collar here for this. But of course you can just make this out of plastic. Just put a end cap there, a cover, and drill a hole to take the shaft. And this is what it should have been. Now I'm gonna move this over to the end of that when I get some half-inch PVC. But anyway, it will fit like that. And once you get this in, I think I marked it. Yep. Of course, it's all waterlogged. I should just, I guess, leave it to dry out and put a whole bunch of cooking oil on it, and that will help waterproof it a bit. But anyway, this works pretty good. And like I said, these are homemade valves. You can see the marble in there. When I went to Home Depot, I think it was last year or the year before, I can't remember. I went too late. It was after the irrigation season, so no check valves were around. So I just made these two valves with marbles. I had some marbles kicking around. Yeah, so that's it. The experiment worked. I hope you guys like it. And I hope the design of the piston will help you guys here in South America, Africa, wherever. Effective little pump. You can use it like a lot of different places. You can use it at your cabin, your cottage. Have it as standby emergency in case, you know, when you know what the preppers say when SHFT. Yeah, no electricity, you still have the ability to move water. Especially, let's say you collect rainwater and then you want to pump it to an overhead tank and let it gravity flow into your kitchen for cleanup and stuff like that. Okay guys, hope this helps.